All right, so let's get started with part 3 of our caster assembly modeling process. So what we've done up to this point is we've finished the top plate. We've worked on we finished the axle support, and we've mirrored it to create the left axle support. We've made sure that we follow the proper procedure for the hierarchy of the components, right? So this is a component, this is a assembly symbol. So these are all components under the caster assembly. We've also we're also following a top-down assembly modeling workflow. Okay. The modeling of it is going to be the same if you're doing a bottoms-up approach. It's just you're going to be modeling each part in a separate drawing file and then just inserting them into the assembly file. So in terms of the hierarchy, that is handled a little bit differently, a little bit more straightforward. But now we want to move on to the bushing in the axle, or the bushings in the axle. Okay, so we want to build these in place. Again, that's kind of what we're doing. It's what we did with the axle supports. Build them in place, meaning that we use the geometry from mating components to create the new components. And it's really a great way to design. It's very straightforward, and it's also very it's how you would design if you were designing by hand, something out of wood, or something from scratch but using your hands. So anyway, so let's move on to the bushing. That's the first one. We're going to build it. I'm going to build it on this side, just because it's the first side that is easiest to access. So it's going to mate up against this face of the axle support. So that's going to be my sketching surface. So again, let's go through the process for creating a new component. I want to make sure I'm in the top level hierarchy, that is the caster assembly, and I can go up to new component. In fact, maybe I'll show you another way to do this. Rather than going to new component, I'm just going to go to sketch, okay? And we'll sketch on this surface. And this is kind of annoying because it's obscured, right? I got the other axle support right in front of it. So how do we fix that? Well, this slice right there will slice your model to the level of the sketch plane. I love using this slice. It just cuts right through and boom, there we are. So we want to project, right? Because we want to pick up that geometry. So I'm going to project. I'm picking up a lot of these other features in here, so I don't want to do that. So I'm going to project, and well, I'm just going to pick them up. It doesn't matter. I can ignore what I don't need. Actually, let's go back here and let's do that one more time. Project. And I should be able to go to body, and let's go this way. Let's pick up that, and let's pick up this, and we'll pick up that. Okay. Now there's some extra stuff in there that I don't really need, but I got what I need, which is the circle and the outer circle and the inner circle. So at this point, just to simplify things, I can turn off the axle support, okay, and then that'll get me what I want for the construction that I'm going to be working with. We want the only thing else that we need is the inner hole right here, and that's going to be a diameter of 16. Okay. So let's finish our sketch. Let's turn it over here. And now we want to, now we're going to do a couple of different things here. Because we actually, from this sketch surface, we want the outer flange of the bushing to grow or to be extruded to my right, to your right, right, this way. But we also want the cylinder here to be extruded to the left. So we're going to have to reuse the sketch, which is not a problem, but you know, I'll show you how this is going to work. So let's extrude first. Let's make this part. So I'm going to pick up that. I'm also going to pick up this inner ring, right? Because we just want the hole to be shown there. And I'm going to extrude this. This is going to be 7 millimeters, right? Okay. So there's the flange of the bushing, okay, the part that sits on this face of the axle support. So now I want to turn that sketch back on. Oh, you know what? No, let's go back. I made a mistake. What I did was I extruded, but I extruded on the caster assembly. So I don't want to do that. I'm going to go back and I'm going to right click. Again, I'd like to say I did this on purpose, but you know, maybe if you believe that, it's okay. But I'm going to go down to my extrude command or my extrude action in the timeline. I'm going to right click and I'm going to go to edit feature. And here, instead of new body, I'm going to go to Oh, you know what? I think I have to do, let me go here. Let me go to bodies up here, and I'm going to right click on body 1, and I'm going to say create component from body. Okay, I thought I could do it in the extrude, but I can't. So I'm going to do create component from body, and there it is right there. So what I was trying to show you in kind of a convoluted way was how we can just start sketching and modeling and then create the component from that rather than go up to the new component. So it's just another way to create a component. I do want to change this to bushing like so. And now, because I'm going to continue working on the bushing, I want to make sure that I activate that component. Okay. So now, what am I going to do here? I need to turn that sketch back on. And you'll see that the sketch is not here. Where was the sketch? Where did I do the sketch? Well, I did the sketch under the casting assembly, caster assembly. So I'm going to have to go back to this sketch folder, and there's the sketch right there. And I'm just going to make that visible. To reuse a sketch, it doesn't have to be a sketch in the object, the part, the component that you're working on. Any sketch will do, right? So there it is right there. You can see it's not visible, so I'm going to turn it visible, and then you can see the outline right here. And so that's all I need to do. Now I'm still active in the bushing, so I'm going to go to extrude, and I'm going to grab this ring right here, and I'm going to extrude it this way. It's going to be minus 12. And then there we go. Okay, that's it, and I can make this sketch. Now, I will say, let me just talk for a second about the process that I just showed you for making a component from a sketch done in the caster assembly. There is one issue with that, and it's picky. It's, you know, it's getting kind of at a granular level, but where is the sketch for this part, this component? Where is that sketch? Is that sketch in the bushing, the component that it actually is? No. This sketch is in the caster assembly part. So from a strictly, purely, let's segregate everything so that sketches stay with bodies, stay with parts, this process isn't as good as going up here to making a new component and following through like that. So it kind of depends on you know, how picky you're going to be. You can imagine that in a in a large company where there's standards for how you do things and where you're going to be working with other engineers and designers to have things done, there has to be a strict protocol for how these things are going to be handled, how you're going to create components, how you're going to, you know, do sketches and all that stuff. Or else it's just going to be the Wild West. Everybody's going to be doing their own thing. And when you're given a drawing to finish or to work with from your colleague, and your colleague doesn't follow any kind of procedure that you do, then it's just anarchy. So that being said, this is another method. Maybe it's not quite as good as the one that I started with, but there's my bushing. Okay. So, and we can see how it fits. Let's turn on the axle support, and there it is right in there. So we can see that if I go to the top level here, we can see it fits right in there. Perfect. Look at that. Very nice. Now, let's go ahead and do the materials for this. This is made of bronze. So I'm going to go to physical material and metal. And we'll scroll down and find bronze, bronze, bronze. What kind of bronze do we want? Cast bronze? No, this is probably going to be machined because we want it to be smooth because it's going to be dealing with rotating parts. So we'll take that bronze up there and then we'll just drop it right in here. And there we go. All right, and we don't have to deal with the finished surfaces because it's all going to be finished. Okay, so there's my bronze bushing. I need to get the other one in there, so we're going to go through the same procedure as we did before. From the caster assembly hierarchy, the top level, we're going to go to, let me zoom out a little bit. We're going to go to the mirror command. And what are we going to mirror? Well, here we're going to select the bushing. Whoops, let's go to component. We're going to select the bushing. All right. And what is our mirror plane? Well, our mirror plane is, because we were smart, the center plane right there that bisects the part. And we'll say OK, and then we have our other bushing right there. All right, so far so good. All right. So last thing we want to do here, let me save it while we're here. It's always good to save it intermittently. Last thing we're going to do here with this video is we're going to draw the axle. We'll try to draw the axle using the same kind of procedure here. But I'm going to do the way that I kind of favor. I'll make a new component here. So again, make sure if you do a new component but the bushing is highlighted or any of these other parts are active, then you're going to be making a subcomponent. All right, so just remember, get into the habit, make the caster assembly your top level, go new component from that, and we'll call this the axle. Axle does not have a W in it, and we'll say OK. All right, we're ready to go. So I'm going to sketch on this surface again, and we'll slice it, and we will project these edges in here like so. Probably don't need all of those, but that's good. We have a diameter of 16. Okay, so create that. Diameter 16. Always make sure your parts are constrained. Always make sure your parts are fully constrained. Diameter 16, and while we're here, I'll just go ahead and do the other one. A diameter of the large part is a diameter of 22, so we'll go out like this. 22. Okay, and that's that. So we'll finish the sketch. We will, let's hide this axle support because it's going to kind of obscure, and we'll hide the bushing because again it's going to obscure what we're doing here. And we need a we're going to first extrude here with a minus 16 millimeter. Oh, excuse me, minus 20 millimeters. Okay. And then we're going to reactivate that sketch. Now look, where's this sketch? This sketch is here, right? Because we followed that procedure. So we'll turn that sketch back on because we want to grab the, oh, you know what? I did the wrong thing. Let's go back to this and edit feature, and let's deselect that. There we go. I love Fusion. Going back in time is the greatest thing ever. If you've worked like I have with AutoCAD and other software packages that don't have a timeline, making that change is not the easiest thing in the world. But with Fusion, being able to go back in time and make that change, it's great. So I did the wrong diameter. So let's go back. We have the sketch on. We're going to go and extrude again. We're going to pick this, but make sure you pick the inner one or else you'll make a hollow. And then we're going to extrude it 40 in this direction. Okay. And then we just got to finish it off right there. Now there is a gap here because the axle does not sit against the face of the bushing. So when we get done with it, we'll move the axle a little bit to the right to center it. So, but here we will go ahead and let's go to sketch a new surface. Sketch on here. Oops, can't get in there. Nope, let's turn off this axle support. There's just too many things in the way right now. Here we go. And we'll draw that and we'll dimension it 16. Finish the sketch, and then we'll extrude this 20. Okay, so far so good. Let's turn that sketch off. We need to chamfer the ends, right? The chamfer on the end is a 2 millimeter by 45 degree chamfer. By the way, let me just explain this. So this note right here, this is the 2 by 45 degree chamfer. This is not two chamfers of 45 degrees. Okay, this is not the number 2 chamfer. That is one chamfer here and one chamfer here. This is 2 millimeters by 45 degrees for the size of the chamfer. There is a chamfer on each side, but this too. Now, how do I know that? How do I know this isn't a multiplier? And how do I know it is, in fact, a dimension? Because of the space after the 2. Okay, so according to the ASME, American Society of Mechanical Engineering, dimensioning standards, when you are intending a number to be a multiplier, that is, we have 4 holes, so it would be 4x for the 4 times 4x. When you're intending a number to be referred to as by, like 2 by 45 degrees, then you include a space. So because there's a space here, I know this is a 2 millimeters by 45 degree chamfer. Okay, so let's chamfer that. So we go to modify and chamfer, and we select this edge right here, and it's already set equal distance, which is 45, so I just got to go 2, and we go like this, and then we do the same on the other side. Right click, repeat chamfer right here, 2, and we're good to go. Alright, so let's turn everything back on so we can see what we have. And let's go up to the caster assembly and activate that. And there we go. Okay. Now, I do want to move this slightly, and we could figure out what that needs to be by doing a little measuring. So we know that the middle section on the shaft, according to the drawing, is 40 millimeters. So let's measure from this edge to this edge, and that's 42. So 40 minus 42, or excuse me, 42 minus 40 is 2 millimeters, and we want it centered. So we're going to shift the axle 1 millimeter to the right. Okay, so shift the axle 1 millimeter to the right. Now here's a thing when you're using the move command, or when you're moving objects in Fusion, we want to be at the top hierarchy. Okay, so I'm at the top hierarchy. I'm gonna go to the axle and I'm gonna right click and go to move copy, right? And then all I'm gonna do is grab this arrow, which is gonna allow me to move linearly in the X direction, and I'm just gonna move it right there. Whoops, it moves 5, so I'm just gonna type in 1, and then we go. Now up here, notice that this is kind of like a check. It's saying, hey, did you really want to or intend to move it like that? Do you want to keep it right there? If you don't, then you can send it backwards or send it back. So sometimes you want to move something just to see how it interferes, to see whether there's room or space or how it's going to fit. But then you ultimately want it to go back. So this revert is kind of like the undo command for the move or copy. Of course, we want to capture the position. So we're going to capture that there. Okay. So our timeline is good, right? Our part is good. Oh, I gotta do the material here. This is a SAE 1020, which is a steel. So let's go to right click, physical material. Let's go down to SAE 1020. It's also the same. The AISI is the same. So we can choose. We have a this is a steel. AISA is just the standards organization. Steel AISI 1020, right? And this has to do with the carbon content and other content of the steel. What type of steel it is? 107 HR means hot rolled. And then this is annealed. Okay, so the annealed is where it's going to be slowly cooled. Hot rolled is where it's going to be hardened, right? So hot rolled is going to be hardened. Annealed is going to be a little bit softer. We probably want this to be a little bit softer. Not that it makes a big difference for this, but just, you know, from an engineering point of view. So we'll take the annealed version and we'll drag it over here, and then that's that, right? And we go close, and let's go back and admire our handiwork here so we can look at it from there. It looks all good. All right, there we go. And last but not least, we're going to do the wheel, and we'll do that in our last video. All right, so until then, talk to you later.